Welcome to this episode on T1.api, the automation solution for T1. Around the world at all time, hundreds of hardware-in-the-loop systems execute automated timing tests using T1. They collect timing parameters, such as CPU load, core execution time, or response time. They also ensure no timing constraints are violated, a basis for safe and reliable embedded systems. In this video, I will show how to start automating the timing measurements of an embedded software using T1.api. Compared to the graphical user interface, T1.api runs in the background, listening to HTTP requests. It allows to easily control T1 from most programming languages. It also provides a web page with interactive documentation, meaning that with a target board connected, you can easily test T1.api commands before writing the automation script. This is a perfect solution to try the API. First, start T1.api. With the executable T1 console.exe in the installation folder of T1, by default in C, Program Files, Gliwa, T1. It opens a terminal showing some information such as the possibility to display the T1 help, using the H or F1 keys, or how to quit. It also displays the HTTP requests received as we will see later. Let's have a look in a web browser at the indicated address running on localhost at the port 9001. This web page shows two links at the top, one for the release note specific to T1.api, and the other for a documentation page on how T1.api works and how it can be used. This can be very useful while writing a script for some standard or advanced usage. This page then contains all the endpoints of T1.api, with each endpoint implementing a functionality. Some endpoints are used to retrieve information, while others are used to start actions. If I expand the info T1 host software entry, I can see information about what it does in the implementation notes, get information about the currently running T1 host software instance. I can also see what is the response class, an example, and finally a Try It Out button. Clicking on it sends an HTTP request to the URL shown here. The T1.api receives the request, displays it in the console. The answer is then shown in the response body by the browser. I can obtain this way the version of the T1 host software installed and some license information. If I want to execute an action, for example if I want to log a message in the console, I can use the print message command in the common endpoints. This endpoint takes two arguments, one for the log level and one for the message we want printed. Clicking on the button makes the T1.api log the message and show it in the console. If I would like to start measuring my application, as with the GUI, I would need first to load a T1 project file. For this I would use in the project API, the load endpoint. I can see that this endpoint is asynchronous, and some information concerning asynchronous endpoint is displayed. An asynchronous endpoint execution results in the creation of a job, identified with a globally unique identifier returned by the T1.api. This job is dedicated to this endpoint execution and its GUID allows checking the progress and the state of the job. Now let's try to provide the T1 project file path in our first required argument. We can keep the two others optional empty, the default value described will be used. Let's click the Try It Out button and see the T1.api return the job GUID. Loading a project takes some time, which means that I must pull on the job state to complete before doing anything else with T1.api. In the job API, the endpoint/API/jobs/ID allows to follow the execution status of a job. By providing the job GUID of my previous endpoint as argument, then clicking on the Try It Out button, it returns the job information. I can see here that the job state contains a state type, completed, and in the execution messages, only some information messages. A job starts in the state type in progress and stays in that state as long as it is running. At some point, its state type switches to either cancelled, faulted, or completed. It is important to note that these state types are specific to the job execution, not the action behind the job. The execution messages are here for that. For example, if I provide a wrong path for a T1 project file to the previous loading endpoint, the loading of the T1 project file would fail, but the job in itself would end up in the completed state because it completed its job trying to load a project file. The execution messages would contain an error message indicating that the file was not found. Now that the T1 project file is loaded, I could start a focus measurement on some tasks, download a T1 scope trace, or instrument some functions using T1 Flex. But instead of using the web browser, it would be more convenient to use an automation script. This will be the subject for another video. Thank you for watching this episode on T1 API, the automation solution for T1.